Hi students, welcome again. So here we are going to discuss a previous year question of the JEE Mains. In this question, it is given that a block of mass is placed on the horizontal surface with vertical cross section y equals to x cube divided by 6. Now this vertical cross section I have represented like this. Okay, I have taken y-axis and x-axis, and we know when the x is positive then y is going to be positive, but when the x is negative then y is also going to be negative, because it is y equals to x cube divided by 6. X cube will be negative when x is negative, right? So the surface will look like this for this object. Okay, and now the question is, if the coefficient of friction is 0.5, the maximum height above the ground at which block can be placed without slipping is. So like you might have experience, like if we take a surface like this and you want to go on this surface, so you can go up to some extent of height. After that there will be a sliding because of gravity's component in this direction, that will increase, but friction will not be able to support that, right? So that is the basic question, but little bit mathematics we need to do here. Like they have given the y equals to x cube, so we x cube divided by 6, so we need to use that, right? So in the solution I have taken this diagram, and let's suppose this is the theta and this is the height edge. At this point it is starting to slide. I am taking this edge height. At this point it is, let's suppose, starting to slide. Okay, at this point I am drawing a tangent. Why I am drawing this tangent is because we know that if we draw a tangent, then the contact surface at this point will be in the tangential direction. Okay, so for the contact surface we can take this tangent, and normal to the contact surface, this normal will act. Okay, and along the contact surface in upward direction friction will act. Why? Because the object is having a tendency to go down, and there is a mg will act perpendicularly in the downward direction. Now look here, if I break this mg, so first of all I need to find out the angle. Generally, like if we take an inclined plane, we will take the this as a pseudo axis, x-axis, and this is y-axis. Okay, let's suppose this is x dash, which is pseudo axis, and y dash. At the x dash and y dash, in the direction x dash and y dash, equilibrium will be there, so total forces will be 0. To apply the equilibrium I need to break this mg into the components. So if I take this angle theta, then this angle becomes 90 minus theta, then this angle becomes theta, right? So then I can say mg's component in this direction is mg cos theta, no doubt in that, right? We can break any vector into the two components. The direction in which we have theta, in that direction we will get cos theta component, and perpendicular to that we will get sin theta component. So in this direction we'll get mg sin theta. Okay, now let's come to this condition of maxima. What is happening? Okay, so we are increasing this height gradually from here. We know that when we go in the upward direction, theta is going to increase, right, as we can see in this diagram. So because of that, mg sin theta component is going to increase. This component is going to increase, and this component is going to decrease. When this component will increase, this component will decrease. At some point the mg sin theta will become equal to the f limiting, static limiting. Beyond that friction will not be able to balance. So if you increase the height again from this point, then after that the sliding will start, right? So from here we get to know the condition for the maximum height. Okay, so I can say what is the condition for maximum height. So for the condition for the maximum height is that the mg sin theta force will become equal to the f static limiting value. Okay, we know what is the f static limiting value, that is mu multiplied by n. N is the normal between surfaces. Now if we take this diagram and the y direction, we know there will be total forces 0. So total forces in y direction are 0. So then n is equal to basically mg cos theta, right? So I can say here that the mg sin theta is equal to mu n, and mg sin theta becomes equal to mu multiplied by n is mg cos theta. So mg is cancelled out, then we are getting tan theta equals to mu, and mu is 0.5, so tan theta is basically 0.5. It means we know that at an angle theta equals to tan theta equals to 0.5. After that, this object will start to slide. Till this point, it will be in the equilibrium, right? Let us find out the corresponding x or y coordinate from this tan theta. Tan theta is the slope of the tangent, right? And this is the our equation of curve. We know differentiation of the curve gives us the slope of the tangent, right? So y is x cube divided by 6. So if I do dy by dx, that is 3x square divided by 6, that comes out to be x square divided by 2, right? That is our basically tan theta, because slope of the tangent is equal to tan theta. So right now we got this condition that tan theta is 0.5. So I can say x square divided by 2 is 0.5. So x square is basically 1. Then x answer is plus minus 1, right? We know from this diagram that we need to find out the maximum height. So that's why theta x equals to plus 1, we will take it. So at x equals to plus 1, it will start to slide. Now, but we need to give the answer of the height. Okay, so y equals to x cube divided by 6. Y is basically the height. I know the x coordinate, so I can place this in the function y equals to x cube divided by 6, and I can find out the y coordinate, which will be the height. So y coordinate is 1 divided by 6 meter. So this is the maximum height. This is our maximum height at which it will be in the equilibrium, beyond which it cannot be in the equilibrium, right? So 1 by 6 is the answer for this question. I hope you have understood. If you want to learn more the concept, then you can subscribe our channel. Thank you.